Brother Dale, what have you got there?
Well, what we've got here is our second generation Tesla coil. It's quite a bit like our first generation, but we've made a couple small tweaks with the primary coupling, so we don't have to have that big dielectric plate on the top there. So it's a little more compact. And what we've got here as far as components, we've got our 12 volt transformers going into our board here, a couple of MOSFETs going up to our primary. It's just a single turn going one way, single turn going the other way. It's a Skori 3 design that I built it with. The secondary is a 30 gauge wire. It's 1800 turns, and that's what we found to be the best combination of turns and gauge. We tried using a 36 gauge and a 34 gauge, and those worked well, but not as good as this. And so this is what seemed to be working the best. So a 30 gauge, 1800 turns. And what we've got over here on the side over here is a buck converter. That's knocking down our 12 volts, which I've got hooked in series down to a 13 volt for our interrupter, which is a 555 timer circuit. So what we're going to do is fire this thing up, and we're going to show you what it'll do. Initially, we're going to do a demonstration with our fluorescent light and our incandescent light bulb and show you what it'll do to those. And then we'll move on to doing a cross induction on a secondary that I'm going to be using on another project later on. So I'll go ahead and turn the light off, and we'll turn this guy on here and see what happens.
Yeah, and just so you guys know, this is the third take on this. The first two, it stopped recording when I got too close, and it kind of freaked out my camera.
So because of the fact that we don't have a breakout right now, we're getting just a whole bunch of a real heavy electromagnetic field, which is doing a really good job of lighting up my, my fluorescent light. If I get too close, of course, it's going to do some arcing. If I can get about 4 feet away before it starts to dissipate, actually quite a bit further than 4 feet away right now, I'm probably closer to about 10 feet away. I've still got a good light going on here, so that's pretty good actually for energy transfer.
Yep.
So I'll show you what it'll do here with an incandescent light, kind of like a homemade plasma globe. I'm going to turn the volume up a little, or the frequency up a little bit here. There we go. That's full throttle. So there you got that. I'm going to go ahead and turn it off, and we're going to pull down this breakout point here and see what kind of arcs we can get with a breakout. Before we were getting about an 8-inch arc, so we'll see if we can duplicate that again. So we're still getting about 8-inch arcs. Looks like a pretty good energy transfer, and I really wouldn't expect to get much more than that out of a 12 volt, well actually 26 volt system. So we're pretty happy with it. We're going to do a little experiment here with our other secondary, which is just sitting here, not hooked to anything. I'm going to go ahead and hook up the ground to it, and we're going to do some cross induction with it. So we'll see how this works. Hopefully the cat won't get in the way. Happy or Kit, go on.
Here comes our cat.
You don't want to be here. Actually, the cat's kind of used to this kind of thing. She's been around here since the first time that I built our first solid-state Tesla coil. So she's pretty much she's used to it.
It's a good demonstration of a wireless energy transfer here, though.
I'll crank it up a bit here. You can see how bright that is. This is coming off a secondary that's not attached to any electrical wiring at all. It's just getting a cross induction from our first coil here. And doing a pretty good job of it, actually, I think. And of course, no demonstration is complete without having a pear or an apple or a banana or whatever sitting on top of your Tesla coil and getting a little bit of arc coming off the top there. So we're going to do that here. We've got a nice juicy pear. If I can get it to sit up there correctly. There we go. And get some arcing off that little guy. And there you have it. Fun with a tabletop Tesla coil.
Yeah, I gotta say, even though we're not putting out 10-foot sparks all over the room, this thing is a blast. It's fun to play with. You're not gonna electrocute yourself to death with it. And,
yeah, that's the nice thing. It's fairly safe, and it's still, you know, it shows what you can do with just a little bit of voltage and a little bit of know-how. Unfortunately, I can't take credit for the, you know, for the all the math that went into constructing the electronics of this, but it's still quite an achievement what Tesla did 100 years ago. So that's it.
All right, thanks for watching.